Hey there and welcome back to the Code channel for a brand new video, and in this one we will make a deep dive into the logger.BeginScope method that we have already looked into in some other video where we did an introduction to these begin scopes and the entire idea of using scopes when logging, which is very powerful, and you should definitely do that. So if you didn't watch that video, you can find a link here in the description or somewhere here in the corner up right on this video. Just pause this one, click on that, view that video, understand exactly why we use this begin scope and logger scopes, how that might be useful, and then please come back to this one, because here we'll actually try to understand how this idea of scopes work with the iLogger interface. Because at least for me, it was a little bit problematic to understand exactly, okay, but what does actually a logging scope mean? When does it start? When does it end? How does the iLogger behave if we add certain scopes in certain stages of the same logging request, for instance? And I just really wanted to take a look into that, and right now I want to share that information with you, and hopefully you might find it also useful when you will work with logger begin scope from now on in the future. So let's get right into it with a very short overview of our setup here. And that's actually the setup that we have used during our last video regarding these logger scopes. I guess the only thing that we have made different here, because there is a very important reason why we did that, is that we have changed this method to actually be async, and also the service call that we make should be async. Now in the service, actually to really, because we don't talk to a database, to simulate actually that we are doing some async work, we have just here this task delay that we await. Now, thing is that here when we do the logging in our controller, we wrap everything into this logger begin scope method, and we call this get scope information, which in turn gets us some type of information like the machine name, the environment, and the app name. Now, the machine name, we take it from this environment class. For all the other values, we have here hard-coded values, but in a real application, you might use or read this from an app settings configuration file. However, that's really not the scope of this video, and I guess it's also not too important right now. The idea is that we have here this kind of logging, and all the things that we log here in our controller are actually wrapped into this logger scope. Now, this means, of course, that probably the scope will begin right when we start this using block, and will be disposed most probably when we actually get out of it, which is true probably. But the question arises, what happens, for instance, with our service? And let's go to our service class. And in our service class, we see that we also do some bunch of logging. However, here we do not use a logging scope. Here we just log the information that we want to log. We have this task delay, then we log some other information, and then we return the results. So this means that in the controller actually, and by the way, we are using iLogger of T. So what this actually means is that when we get here, we will get a new instance of this iLogger of weather forecast controller, and when we get in the service, we will get a new instance of the iLogger of weather forecast service. However, these loggers are actually singleton, or iLogger of T is always singleton in ASP.NET Core. So it means that the first time it is required, a new instance gets created, and afterward, the same instance will be reused throughout the entire lifetime of the application. So that's the theory behind this iLogger. Now let's run this application and make this very dummy request. And probably the Swagger page will open on the other monitor, but I will not bring it actually over here because it doesn't actually make sense at all. Instead, what I will be doing here is I also have configured here in this application logging to seek with Serilog. And I will just want to try this out, execute the request, getting the results, and do a refresh here. And let's look into what we have in Serilog in Seek, and try to understand actually what happened. So the first information that is logged is, of course, in the controller, where you see that request was received by the controller, and we have all this type of information. And we see that all the information that we have put in that login or that logger scope is here. So we have the app name, which is exactly what we have provided. We have the environment, which is exactly what we have provided. And we have the machine name, which is taken from the environment class through the machine name property. So that's actually working fine for now. And of course, there are a bunch of other things that are still logged by the same controller, like this is the dispatching method. But then this is the other method, which is getting data from repository, and that is actually logged by the service. And if we can take a look at that, we see that even if that is logged by the service where we have not configured any logger scope, we still have here these logging scopes as the app name. We still have the machine name here, which is the same one as it was previously. And we have the same value for environment, which is development in this case. So the first thing that we actually notice here is, and let me go back to Rider, is actually that even if we don't actually use logger scopes here in our case, in what we have here in our service, all the scope information that we have added in the controller is still visible here. Now, how is that even possible? So to understand that and how this actually works, I would like to do the following thing. I would like to put a breakpoint here, and I would like to put a breakpoint here when we actually use the first time this logger in the service. And this time I will run this application again, but I will run it in debugging mode here in Rider with Alt and F5. And we will see exactly what happens if we go then step by step. Of course, I have to first kill the previous running of this application, and let's just run it again right now. So once again, it's exactly the same thing, but the only thing that we want to do right now is just look into what happens when we get to this type of breakpoints. So yeah, we have executed here, and we are here in this method, in this controller action, actually, where we do the first logging, and we have already created a scope. So let's look into this logger. Of course, since we are using Serilog, and Serilog, what it does actually when you add Serilog, it clears all the other providers that you might have from ASP.NET Core, and it just adds Serilog, and that's it. But this behavior is actually very, very similar throughout most of the different logging providers. So there shouldn't be too many differences in what we actually go through right here. So if we expand this, we see here, okay, that we have some private fields that we can actually look into. And one of them is the provider, which is the global Serilog provider that's responsible to create different loggers and things like that. We are not really interested right now in how Serilog works, because once again, even if we take a look here at a very specific logger or logger provider, the implementation of this type of logger scopes is very, very, very similar, almost 100% similar throughout most of the different logging providers. So if we see here, we have this value, which is an async local of Serilog logger scope. And this means that actually Serilog creates this logger scope for us. And we'll get into this idea of why it is using an async local just maybe in a few minutes. But here, if we go here in these values, and if we go on state, we see that we have here our three properties that we have defined right now. So we have the machine name, we have the environment, and we have the app name. So this is what actually the logger will use right now as a scope when we start to log these first logs. And that's exactly what happens. So if we just run this first one, and if we take a look right now back into our SIG, and if we do a refresh, I guess it's not logged yet. Probably it will log everything at the end when everything completes. So the idea is that right now, let's skip ahead so that we can get into this service. And here we have a new logger, which is a logger of weather forecast service. So the logger instance is different. However, this logger belongs to the same logger provider. And if we take a look at the provider right now, we see that, okay, we still have this current scope here, but here we have this value, which is once again async local of Serilog logger scope. And here, if we go in values, in this state, we see that we have exactly the same three properties. So what this actually means is that once this type of scope is created, all the loggers that will be used for that provider in that specific instance will actually look into this Serilog logger state and see exactly, okay, I have this type of key value pairs. So I will write them. So this is actually what happens under the hood. And that's why even you don't wrap this thing here in our service in a BeginScope method, then of course the thing is that it actually will use all the existing information that actually comes from the parent. So from where we had or where we added our scope information in our controller. So let's just click, no, I don't want to do this, but just this one. And we actually finish everything up. And if we take a look, it's actually exactly the same what we had previously. So we have this request started and we have all this information. And when we look into these logs that were provided or created by the service, we get the exact same information and also this one. So there's nothing very, very different here. Let me here just delete all these matching events because we want to run something else right now. Okay, so we would say that's kind of nice. But what happens for instance, and let's just remove this breakpoint for a while, if I want to here also add something or some scope information to that. So we can totally do that. And for this, we actually have a method here. This is get scope information. Let's comment this out for now because we will use this just in a little while to actually understand why that async local call or why that type is an async local. And I don't know, let's just take here something from here, but we'll give that a different value. So let's take this and we will actually move that here and we'll give here, let's say this is the production. Okay, so let's put once again, of course, we need to also wrap everything in a using. So it's be using. And once again, this logger.BeginScope. And here we want this get scope information. And sorry for the typos. These are actually from the last time out. So good that IntelliSense or how that might be called in Rider is working okay. So we don't have any problem with that. So right now we have actually wrapped everything into a scope that is actually created here in our service. So let's once again put here a breakpoint. And we also have this breakpoint in the controller. And I would like to actually take us through this whole process once again and understand exactly what happens now that we also have added a logger scope to our service method. Okay, so let's just start the application. It will open Swagger on a different window, but once again, I will not bring that here because it doesn't really make sense. I'll just get that request going and then we will look into what we have there. Cool, so we have the request and Rider already tells us that, hey, there is something here, but why? Okay, because sorry, that was my mistake. I didn't run this in debug mode. I just ran it. So that's why we didn't hit the breakpoints. Should Alt F5. Now it should be correct. So let's do this once again. And then let's take a look at what we actually have and how these logger scopes actually work here. So execute. And yeah, right now we hit the breakpoint. So once again, if we go here, we are on the controller, we look into the logger. It's exactly as last time out. If we look into the provider, we see that we have this async local value. And if we look into the value, we see this state that contains these three scope information, three scope key value pairs that we have provided. So until here, there's nothing really special to that. However, let's also go one step further. And right now we entered our method here, which is in the service, of course. And let's take a look at the logger right now. So if we take a look at this logger, and once again, we need to take a look at the provider always. And here we say that, okay, we have this value, async local of Serilog scope. And in this one, we have a value. In this value, we have a state. And in this state, we see that we have already here the thing that we added right now, or the key value pair that we have added here in the service. But right now we see that here we also have this parent information, which is once again a Serilog logger scope. And if we look into that, we go into state and we see the exact same three variables that were also defined previously. So if we take a look at those, let me just expand this. So we have, let's take a look. We have this this key value pair, which the key is environment. So from the parent scope, that one is set to development. But from the current scope in which we are in, this that one is set to production. So what did happen in this case? We see that we have actually the same key, but with two different values. Now, in this case, the way how this will behave is, of course, it will give precedence to the key that it finds here. So it will write this environment key that it finds here in the current scope, but for the machine and the app name, it will write the values that it finds actually in the parent scope of that. So if we just run this application, let it complete, and if we change right now, once again, to our Seek server, and let's do a refresh here, and let's see. So request provided by the controller. So in this case, we see that this is the machine name, this is the environment, and this is what we have to note, and this is the app name. So let's look now into a log that was generated by the service. And right now we see that the app name is still the same as previously. We see, however, that the environment, this time it is production. And once again, remember, because when in the different levels of scopes that we might have, if the provider encounters actually a key that is actually the same, it will always prioritize the key in the current scope, and it will take that value, not the value from the parent scope. Now, for the other two, like for the machine name and the app name, as we have not provided any value in the service or the scope that we have defined in the service, it will just reuse the values from the parent scope. And this is actually how this type of begin scope actually works. However, there is one other point that I would like to actually go through. And that point is actually about async stuff, because you see that regularly or normally in controllers, you would have an, let's go to the controller, by the way, you would have an async task of iAction result. Then you might probably call a service that's also async. That service might call a repository that's also async. So mostly everything is async from the top to bottom. But what does this actually mean, this async stuff? Well, of course, we could spend here, I don't know, maybe 4 hours discussing what async and the way it means, how the task work, how the task class works, and different approaches that we might have to asynchronicity when we are developing .NET applications. But of course, that's not the scope of this video, so we will not have right now a deep dive into those topics. However, as a main idea, I would say that, of course, this means that, hey, when an operation starts, if it's async and if it has other async operations in itself or depends on other async operations, it means actually, so if we use this kind of like default implementation or default way of working with async and wait, it means that, for instance, sometimes actually maybe this process f temperature might work actually or might run on a different thread than the controller action itself. Now, of course, if that runs on a different thread, that might be a problem for the logger. If the logger is, well, not thread safe, it wouldn't have actually an opportunity or an option to pass in or make this scope information available throughout the different threads that might arise here. So to kind of like try to simulate, because we never know exactly if or when a new thread is created for an async operation, we'll actually try to bypass it and kind of like force a little bit that it should create a new thread here. So we will have this task.run, and we will simply use this task.run version, and this pretty much will mean that in most of the cases, this process f temperature will actually run on a different thread than what we have than on what actually this controller runs. Now, to enable also us an option to actually see information about that, we can actually do the following. So first of all, we have enabled this other current thread key value pair that kind of like takes the thread ID of the current managed thread, since we are not creating the threads by our own. All the threads are managed by the platform. We just get the ID of the managed thread on which this one actually runs right now. So exactly the same thing we would have to do here in the service. So we have this scope information, and yeah, let's kind of try to actually run this application once again in debug mode, and see what we can learn from that. So let's start it in debug mode as promised. And we shall take a look just in a few seconds about what will happen here. Once again, Swagger will open on the other windows. So, oh, this time it opened here actually. Okay, that was strange. Okay, let's just execute this one and execute. And okay, right now we are back here. So we see that we are in this controller right now. So let's take a look first of all at the managed thread ID, which is 8 in our case. And if we take a look at the logger once again, if we look at the provider, we see once again that we have this current scope. And in this current scope, we have this state that contains actually 4. Of course, the current scope has also a parent scope that comes from Serilog. And you noticed maybe in Seek that you have a lot of other information like the request ID, the request path, the source context. All that information is actually already gathered by Serilog directly into some scopes that are parent scopes to this current scope where we are now. So this happens before actually our controller gets hit, probably within a Serilog middleware. But we see that we have right now these 4 values, including also the current thread ID. So everything is okay. Now, let me then just go forward here. And right now we are in the service. And let's just already look at the managed thread ID, and we see that it is a 16. So it means that right now we are on a different thread than where the controller runs. So let's maybe go here one step and look into the logger. And we see that actually we have this Serilog logger. If we go to the provider, we have this current scope. And this current scope has a state, and it has a dictionary once again of this environment and the current thread. But it also has the parent. And if we look at the parent, we see that it has the state and it has those 4 keys, including the thread from the controller, which is kind of like nice. And here comes the whole point of actually using this idea of async local, because if we look here into this value, we see this is actually the field, this is the property, the current scope that is actually exposed, but this value is the backing field for that. And we see that this is an async local of Serilog logger scope. Now, of course, it could be an async local of about anything, but the main idea, and this is maybe the key point on how actually these logger scopes actually work very, very fine, even if the request is actually handled throughout different threads. Because this async and local is a way, it is a class provided by .NET for this kind of like async execution context, when you have an async thread of execution, but you need to kind of like also a little bit need to keep the state of what happens in each thread. And the idea is that basically what you set here in the parent as an async local, when you go to the child, that child will also be able to see those values from async local. The child might be able to actually change that value, but that value will then only be changed in the child thread, or well, yeah, it is actually a certain child. And it will not affect the parent. The parent thread will remain exactly the same. And we can actually see that, because even if we are here on a different thread, and even if we here change the value, for instance, for the current thread, which is right now 16, and we also change the value for the environment, actually what happens is that once the execution returns to the caller, in this case our controller, the old scope or the values that we already had in the parent scope will actually be used. And we can actually see that very, very nicely in action if we kind of like go here to the seek and try to look once again what happens. So first of all, we have this controller, which of course we have this environment development, and we have the current thread, which is set to 8. Then we have this method that is logged by the service, and we see that the current thread is set to 16 and the environment is production. So even if those values were on a different thread, it was still able, the logger was still able to understand, because of the use of this async local type, that from the parent it still should actually append here the app name and then the machine name, which was not changed. And then we do different bunch of stuff or logs still in the service, and we see that these are exactly the same thing once again. So the current thread and the production. But once we actually get back to the controller, we see that the current thread once again is set to 8, and the machine name and the environment is once again to development. So it means that this async local is like a sort of option to store some information that should actually be available throughout the entire execution of an asynchronous pipeline. So that, for instance, threads that were spawned up to do some tasks will actually also be able to look into some information that actually was generated or comes actually from the thread that from a different thread. And this is how this async local actually works. And by the way, I think that on this async local class, I will most probably provide here a new video dedicated only to that specific type to understand exactly how that actually works. But for now, I guess that kind of like the scope of this video is done. I just wanted to show you how this concept of scopes in iLogger actually work, with this idea of having always a current state and a parent state, which happen to be actually persisted, let's say, in memory on a type which is async local. But the important thing is that we always, when we add in a different place actually a new scope, that will become the current scope, and then it will have also parent scopes up to the very first scope that was ever created. And should you have at some point conflicting keys or conflicting names in your keys, always the current scope or the value in the current scope will take precedence on the values that might be on parent scopes that might find themselves on different levels on this scope hierarchy. And this being said, actually, I think that's mostly done. Thank you very much for tuning in and watching this video. I hope it was useful. If you think that this content might be useful also for others, don't be shy and feel free to share that with your friends in your social media, through email, whatever means do you actually think that you might find somebody that would think that this content is useful for them, and that of course would be highly appreciated from my side. And of course, subscribe to this channel if you haven't done that already, and make sure you also press the notification bell so that you are always notified when we go live or when we have a new video, because we tend to add content very frequently here. This being said, once again, thank you very much for tuning in, and until the next time, I wish you the very best.